Over the last two streams, we had a look at interfaces, and you've seen how useful they can be, and that will remain true in the future as well. Despite what you see today, interfaces are incredibly useful tools still, for a couple of reasons, but they do have certain limits. And when you hit those limits, there are probably better ways to accomplish what you want to do, using, for example, the methodology, the language feature we're going to look at today. And to demonstrate what we're talking about, let's say we have a couple of... I can type? Where can I? Okay, now I can type. Let's say we have a couple of enemies in our game. So we have... say we have a slime, that's a classic one. And we have a golem, the class golem, and we have dragon. Right, just some different types of enemy we can fight or befriend, maybe. And I want to put them together in one storage somewhere, like an array, a list. Just I somehow want to manage them. And because they're all kind of an enemy, potentially, we also need some stats. Some basics that they all share that will be there for every enemy type. So we use what we learned last time and the time before. We have an interface, enemy. Didn't that song just play? Is it repeating the same song again? I'm sorry, I'm confused by the playlist. I mean, in theory, it's randomized, as in true random, so it's possible, but it's never happened. Not that I'm aware of. Well, we'll see. If the next song is still... what is it right now? Storm Chasers, we'll know that something is messed up. And we'll have to fix that. Going back to the enemies. Let's say we have health. And we've learned that properties can be used inside an interface as well. That's something we have to do, and maybe attack. Ah, wait, no. We don't fill in anything. Attack, need damage. We can attack them with a certain amount of damage, and maybe, let's say, get attacked. That might be better. And another void attack, for which they get... we can make a player class. I cannot type public class player. That, and we have player. Alright. So some basics for enemies. They have a health bar, we can attack them, and they can get attacked. Other way around, so. Wait, we can attack them and they can get attacked. It's kind of... either I win or you lose. Alright. They can get attacked by us, and they can attack us as well. That's better. And we gonna implement that interface. What is wrong with me? I don't even have an excuse today. It's warm, but that's it. Right. And as we learned, the compiler won't like this because this interface is a contract that we apply to slime, golem, and dragon. And this contract says we have a health property, a method get attacked, and a method attack. We don't fulfill those requirements, so the compiler rightfully complains. That means we have to now implement all of these details for every single class. And these are only 3 different variations. What if we have a couple of more? I mean, at least 4, right? A good game should have at least 4 different types of enemy. I'm too lazy to type that out. I don't want to do that. Wouldn't it be great if I could just define the code in here in interface and just say use that everywhere? Maybe the option to make something slightly different if I need to for a specific type of enemy, but for the most part it will always work the same way. Health is just gonna be some field with an integer value that's getting reduced by get attacked, capped at 0 maybe, and attack will simply apply damage to the player based on some criteria. So that might be something we implement per class, but the whole health system with getting attacked, that should be the same for all of them. What if we could just provide some code in here, and for the property as well, that would take care of everything. Oh. Unfortunately, interfaces can't quite do that. That quite is because actually they can nowadays. This is a difference of the language version you're using, which partially depends on what framework you're targeting. That's a larger topic to discuss, but basically there's a sort of shift in technology for .NET, which is the backbone of C#, which means there's a language version 7.3, which is kind of like a milestone. That's gonna be locked in for a lot of projects. And within that 7.3, which is basically what I based all my teachings on so far, and probably gonna continue using, 7.3, this is not possible. This is an interface, it just defines the signature and that's it. Newer language versions do actually have the option to define some code in here. And there are some rules you have to keep in mind how that plays out in the different classes, but we're not gonna worry about that now. We're just gonna assume 7.3, which is still compatible with the newer language version, so it's not like this is useless to learn. We're gonna assume we can't define default behavior. And by the way, even with the newer language features, we can't define a field. A property, sure, but we would still have to implement the property ourselves and back it up with some field in the class if we want to store health permanently. We could also... Yeah, no, we can just define a field on the interface. That's still not possible. So what we do instead is we don't define an interface for enemies. We just define enemies in general, fully functional enemies, in fact. So instead of an interface, public, let's make it a class, enemy. And an enemy will internally, private, and health have a field for health. And public and health. Get return. We'll have a property that we can use to read the health from the outside without changing it directly. Let's say we'll make a constructor, public, enemy, and health. Some value in the constructor that lets us define the initial health. That's better. And yeah, let's keep that. Let's also define the get attacked for now. Public void get attacked. like that. Public void get attacked. And damage will define how much damage we get. Let me go health minus equals damage. And then let's keep it simple if health is... No, let's try to be a bit more clever about this. For reasons we will discuss in the future. If damage is greater than health, let's make it greater or equal, then health equals 0, and otherwise health minus equals damage. That's better. The other way around would be reduce the health first and then check if it's negative and set it back to 0. But that would mean that for a brief period, health would be less than 0. And for reasons we'll eventually discuss, a couple of lessons down, that might have consequences. So I prefer it this way, just to make sure that it truly never gets to negative values. Right, so we have now an enemy. And I can scroll. Let's prevent that issue from occurring again. Better. This enemy defines some base behavior for all enemies. They have health and they can get attacked. And they allow different values for health when we create them, initially. One way we can use this would be by... Let's make it public for now. Public read only enemy. Make it a field inside the slime, for example, and then public slime int health. The starting health, we define it in here in the constructor as well, and then we say enemy equals new enemy health. And then we can also have get attacked. Public void get attacked. Damage. And all we do here is then redirect it basically internally enemy dot get attacked. Damage. And we can... let's make that private maybe. And then public, I'm too lazy, let's copy that out here. Instead of having field with health, health directly, we go to enemy.health. Let's maybe rename this since it's private now. Enemy. Alright. So we have defined one base class for enemy. It just occurred to me, did I write enemy wrong? Okay, no, I have to look this up. I have to look this up now. No, that was correct. Why does it look so wrong to me? Enemy. What word am I thinking of that this looks wrong? It is correct, it's enemy. Weird. We have this base class. Defines what an enemy is. It has the health and it has the abilities for attacking, or at least getting attacked. And we can rely on this field to back up the behavior internally for all kinds of different enemies. I can do the same for Golem and Dragon, and this code would remain basically the same. Can just copy paste. The only thing that has to change is that the constructor, of course, is for the class specifically. But that's it. The rest of the code can stay perfectly same. And if I need some change in the behavior, for example, I do allow suddenly negative values, I only have to change it in here, in this base class. what is an enemy? Well, they can have negative damage or negative health, so just drop this and all of my enemies automatically behave the same way, because they all rely on the same basic class to determine their functionality. Can go further and do public void attack player. Right, we could do that in here, but maybe you should show some consideration. The attack from the interface provides only a player, and the different classes then determine how much they damage a player. So this internally should show some consideration by not being the same as the interface, just the damage, and then let's just make this simple. The player is just a field, doesn't matter. Then player dot health minus equals damage, like that. But then let's make some breaks in between here. Split them apart, it's easier to read. Then a slime can get a public void attack player, and this will internally then redirect this to enemy dot attack player, but also a damage value. Do that in here, and then the golem will hit a bit harder, 10 damage, and the dragon will hit the hardest with 100 damage. So minimal changes for each of these classes here to make sure they have slightly different behavior. But for the most part, this code is the same. I can just copy paste it. It saves me a lot of time. Again, if I want to change the behavior a bit, for example, I can't just deduct health to the limit. Maybe there's if player dot health is less than 10. We can't do full damage, we only do damage. Let's say player.health equals 1. Whoop. Now let's make it and player.health is greater than 1. So if I have a health of 2 to 9, any attack only gets me down to 1 health. Like a last-ditch effort to save yourself. If you're low on health and you get attacked, it will reduce your health to 1. Doesn't matter how strong the attack is. It can be very weak, it will still drop you to 1, but it can also be full dragon attack, 100 damage, and still only get you to 1. But once you're at 1 health, well, the next attack will get you. Like a little last-ditch mercy effort. This is an interesting mechanic. And by changing it in here in this basic enemy template, I've changed the behavior for all my different enemy types. Didn't have to rewrite any of them. And because it's mostly copy and paste, I can quite easily add more enemies. More variety. So that's very useful. And I still make use of my templates. Did I actually compile? Yes, alright. Didn't make a mistake. The interface is still there and valid. I can still have enemies equals new enemy. And let's save ourselves some time. New slime Slimes themselves have, let's say, 2 health. 2 hits at the weakest, and they're done. And let's say there's a variant that has 4 health. Then we have new Golem. They're very tough. And new Dragon. They're only slightly more tough than a Golem. Well, slightly. 2 Golems would still have more health than a Dragon, but Dragons hit so much harder, so... Still a tough enemy. Now, I can still use the interface as a commonality between the different enemy types, and I can still call all the basic functions of an enemy on these different classes because they all share this one contract, this interface. But the detailed implementation for how they handle that is dealt in one single class only, and all the behavior is defined by this one class and lets me have full control over every enemy by making one change in here. Much more convenient. Still a bit stuff to write out, but at least it's only copy and paste. We can do better. Now this is stuff you could have come up with yourself if you haven't already. Pretty basic stuff, actually. Composition. No, is it composition? Yeah, it counts as composition, I think. Doesn't matter. Since we define the basic behavior in here already, and this code is basically just forwarding it to that one base class, to this internal field that stores an enemy, why not tell the computer directly what we want? Why not tell the computer that this is basically what we want? All the behavior is already defined in here. That's the code we really use. That's what's actually happening. All of this stuff is just so we can redirect to that code. That's all we do. That's the only thing that matters. That's all we care about. So, instead of doing all of this, and this, and this, we let the compiler know to please consider this the code we want to use in Slimes, Golems, and Dragons, without writing that out ourselves. And the compiler is happy to oblige, as long as we tell them exactly how we want to accomplish this. And the easiest way to accomplish this is by changing this to this. What the hell is this? Enemy is this class. IEnemy was our interface. Now, colon interface, that makes sense. We implement an interface. We just tell the system, hey, we want to apply a contract to our class. But enemy is a class, not an interface. This is not a contract we apply. So what does this mean? This colon is not just used to tell the system we want to use this interface, we want to implement it. It's also to tell the system, the compiler, the computer, that we inherit from another class. Inheritance is the keyword. What we told the system here is not we fulfill the conditions of a contract. We told the system we want the full content of this other class to be part of us. We want to be this class, enemy, plus some extra. Plus our own stuff we define now in here. but treat all of this stuff that's in enemy already, all of this, as part of us. It's all in here. Pretend all of that code that's written in enemy is also written in slime, and in golem, and in dragon. This code exists in here now. We don't write that out, it just is assumed. We told the compiler, we inherit, we take over the code from that class. That's ours now. That means when we create a new slime, what we really create is a new enemy. An enemy which has a field help, and a property help, and a method get attacked, and a method attack. Those are all stuff the object enemy has. And that's something slime will have, and golem, and dragon. So I can 0 I less than enemies dot length plus I, and enemies dot get attacked. Do I hit caps lock? I hit caps lock. Attacked. 1 damage. This is possible now. Even though we are not using an interface, we can completely drop the interface. We don't care about that anymore. We told the system enemy has the method get attacked. We have the code defined down here, how that works. It relates to a field that we have in enemy. So this is perfectly fine code for an enemy. We said slime is an enemy. Whatever enemy is, slime is that. So a slime can get attacked. We can call this method. This class, public class slime, has a method get attacked. Implicitly, this is still in that class. I'm hammering home on this a bit. I'm repeating myself a lot, but this is such a fundamental, important concept that you need to understand. With interfaces, we simply tell the computer, we agree to the terms of that interface, but we write the code fully ourselves. We commit to a certain standard for the code we write, but we don't get anything handed out. It's just, we agree to the terms, that's it. With inheritance, by inheriting from another class, we don't agree to fulfill something, we simply get it. By default, we fulfill the criteria here because we get the code. There is existing code we just get handed out to. Get handed out. We inherit it. There's nothing to agree to, we just get the stuff. So without writing anything in here, we have a get attacked, and we have an attack, and we have a help. That's all already in slime, golem, and dragon. But this is where things get a bit important. As we had earlier with the interface, these different types had slight differences between them. There were 2 differences in the code we wrote in each of them. One was the attack method. The attack an enemy has a player and a damage. This was so that each class could provide different damage value. So enemy.attack right now is this method that requires a player and damage. The original interface method was only a player. So enemy itself can deal with multiple different types of enemies, because it offers variable damage in here, but we want those classes to only use a specific type of damage, specific amount of damage. So we do need to write something ourselves. Or at least provide the damage in some way that's unique per enemy type. And we could write that out. Let's start with that. Something out attack, which gets just a player. And that will then call attack player 1. I'm gonna write out the others as well. This will look a bit weird, maybe. We've never explicitly mentioned that, but we have this concept of overloads. If a method looks different, it can generally be the same name. So if you assume this is a class that already has that method, that means we have 2 attack methods in here, in the same class. But that's fine. They have the same name, but one gets a player and damage value, and the other only gets the player. So when we call the attack method, the compiler knows you're calling the attack method and provided with 2 values, a player and an int, then you mean this attack method. If you call the method attack that only gets provided a player, then you mean this attack method. That's overloads. You can have the same name for a method as long as the parameters look different. Because the computer can still differentiate between the different methods. It's a combination. The signature is always a combination of the name and the parameters. So even if the name looks the same, it's a different method. The computer sees this as entirely different from this. Fully different method, even though the name is the same, and to us as human, it looks like we have the same method twice. So, it's overloads. I've used that a couple of times already, especially for constructors. Same rules. We've never explicitly mentioned that. Honestly, I assumed that was clear, so I'm just explaining this now in case it wasn't, because it's important now. Anyway, when we call attack on a slime, or generally, let's say, let me start, let's say player. When we call attack, provided a player, like that. Compiler recognizes this as the attack method with only a player, not player and int. So this attack cannot refer to this already existing attack method from enemy. It must be this specific attack method in slime. And this specific method in slime takes the player and passes on to this attack method that gets a player and an int value. So that must mean it must be this other attack method that gets a player and an int. So it looks kind of weird that in the attack method we call the attack method, but to the computer this and this are 2 entirely different methods. So it all makes sense. And this method exists. This code exists, we say we inherit from this, that is our code now, so it's fine. It's as if this was one giant class. We just extended this class. We took this class enemy, which went up to here, and then we added some more stuff to it. And this more stuff is called slime. If it's only this stuff up here, then it's simply an enemy. And everything we write down in slime is just extending the existing class. We take everything that was in enemy and add some of our own stuff to it. Same in Golem, which will hit for 10, and the Dragon, which hits for 100. That's one way to go about it. It's Still some stuff to write out ourselves, but can do that. Now, because we have the attack method defined in all of these classes down here, we can call attack like that. But all of these are enemies, meaning all of them will have this attack method available as well. So I can just do this. The code allows me to call this attack method because it is defined an enemy. It's a public method in enemy. Slimes, golems and dragons are enemies, so I have this method. I can call it. But the intention was that this is only available to these classes here to make their specifics shine through. The behaviors defined an enemy, but some details about how we apply these behaviors should be left to the individual classes we dive down here. So we provided a special method that can pass on a damage value. We did not want the outside world, so to speak, to also benefit from this method. You should not be able to call attack with a specific damage number. It's going against the whole idea we have here. Well, what's our go-to to make sure someone cannot call a method or see a field? We make it private. Now I cannot call attack anymore. It's a private method. I don't see it. It basically doesn't exist as far as I am concerned. So that should work, right? Yes, it does, sort of. We cannot see this attack method, so that's fine. This attack method is public, we can see it. This attack method is private, we can't see it. So the only way to call attack on an enemy is through the specific attack for each enemy type. The issue is, private, if you remember, made something private to the scope of the class. As soon as you leave this scope, as soon as you leave these brackets, it doesn't exist anymore. This health field only exists between these curly brackets. It has a very limited scope. Down here, we call the attack method, but we are no longer within that scope up here. And while I said we basically just extend this, it's one class, the code is all there, some rules still apply, like the scope. Private means private. Even though we inherit from that class and we get all the code, private means, no, I'm keeping this for myself. It's limited to my scope specifically. No one else can get it. I've locked it away. No one can inherit it. They don't even see it existing. It doesn't exist. It's not there. So setting it to public means we can call it from the outside, which is not intended. And setting it to private means even the slime, which is an enemy, can't use it anymore. So that's an issue. Well, maybe you remember me saying that there were other accessors. There were other modifiers to determine how visible something is. And now's the chance to learn a third one. We want a visibility for this method that extends to all of these classes down here, the classes that inherit from enemy, but not to someone completely outside that was to just call the method. And the keyword here is protected. This method is protected. It is visible but only to my direct line of classes. Only classes that inherit from enemy are allowed to see this method. It is protected otherwise. It's passed on to these classes, but not visible to the outside world. So enemy has a public getAttack method, because it directly interacts with the field that's also defined in enemy. We can keep health private, that's fine. GetAttack can be called directly from the outside. We don't need to implement that specifically in Slime, Golem, and Dragon. But for attack, we make it protected because it is not certain how this method will act. We've defined some base behavior, but it needs some additional information from each of these classes. So they make their own version of attack that internally call this more general attack method that only they get to see. Makes sense? Let's move on, maybe. Because there's another thing that was unique per class before. Something else that has some variability to it. Slime can start with 2 or 4, or Golem starts with 1,000, and the Dragon starts with 1,500. The health. And sure, we have a constructor defined in here that gets provided a health value and stores that internally in the field, but this is constructor for enemy. This constructor is limited to this scope. It only knows what an enemy is. It only knows the stuff inside here. It has no concept of slimes, golems, and dragons. So all of this constructor can do is initialize the stuff that's relevant for enemy specifically, which for us is health. That's it. And while right now, slimes, golems, and dragons don't have any other fields, they might in the future. And enemy has no idea what those fields even are, that they exist in the first place. I mean, enemy doesn't even know that these classes exist. So it has no ability to initialize those different classes. This constructor can only create an enemy. Meaning we still need a constructor for slime, golem, and dragon. Which, well, it's okay. I mean, the compiler creates a default constructor for us. So I can just call constructor of slime by going new slime like this, right? Default constructor. I didn't define a constructor in here, or on here, or on here, so the compiler will add a default constructor, and that's that. True. The problem is we did sort of define a constructor, part of it. We have a constructor in enemy. And it's not the default constructor. We have a constructor in enemy that requires a parameter, requires an integer value for health. We don't have a default constructor that can work without any data. So by writing this one constructor with a parameter, we told the system, if you create an enemy, you absolutely have to provide a value. You cannot create an enemy without providing an integer for health. No way around it. Since slime, dragon, and golems are enemies, we cannot create them without providing a health value. Enemies have to have a health value provided when we construct them. Slimes, golems, dragons are enemies. They need to get provided an integer for health. The default constructor doesn't get the privilege of providing an integer value, since the compiler doesn't assume just some random value here. So the compiler says, no, I'm not going to give you a default constructor. you need to provide a value. Default constructor doesn't do that. I'm refusing to create the constructor for you. So in this case, we have to write our own constructor. And I could write... Oop, what happened? I could write a default constructor like this, but the compiler would not be happy about it. That is the default constructor, the one the compiler would create as well, but the issue persists. We don't provide a value for this. Okay, so we provide a help value, I guess. Like this. And it will just magically teleport that into this constructor. That might be a reasonable assumption. Like, we just told them, yeah, it's fine. We just called it slime now, but it technically is this constructor. But, well, this is a method. There's code in here. So does it execute this code in here or this code in there? Or does it execute both? Probably both. But what if I have slimes with a default health? What if I don't want to define the amount of health in here when I create the construct the slime? So maybe I do want the option for a default slime, which doesn't get anything. Where's the health coming from now? Is that possible even? Is there a workaround for that? So the syntax isn't quite that easy. We have to do something weird to these constructors. But it's not a weirdness you haven't seen before. We use a colon right after the method, signature, after the constructor here, but before we define the content, the body of the method. Just as we use the colon to add something to this class definition before actually writing out the class. Same idea. Use a colon and add something to specify some properties for this, some special behavior. And what we define in here is similar to here, where we defined slime as being a class that inherits from enemy. We can add some definition here that says this constructor for slime is based on the constructor for enemy. And I used earlier the term, this is a base class for all kinds of enemies, when we implemented this as a field and used the interface otherwise. Like, this is the basic template for an enemy. It's the basis for enemies in general. And it's also the base class. Slime inherits from enemy. That makes enemy the base class of slime. Slime is based on an enemy. That's the foundation, and adds its own stuff on top of that. But it's all based on enemy. So the keyword base is used when you want to refer to something in your base class. If I write out attack, the compiler will see that attack is part of the base class. I could alternatively also say base.attack. I specifically tell the system, I don't want my attack method, I want the attack method of my base class. Doesn't matter in this case, since the only attack method with a player and an integer is in the base class, so there's no confusion here to have. It's a bit similar to explicit interface implementation, where you have to add the name of the interface before a method, with a interface name dot method name. Base has a similar reason to exist. We want to specify that we're not talking about ourselves anymore. we're talking about something in the base class. And in this case, we want to specify that we are based on a specific constructor in the base class, one that gets a health value. So we basically call the constructor. By default, if you create a slime, you say that please call this constructor in the base class, the constructor that takes in one integer argument. There. This might look a bit more consistent to you, but writing out the name of the base class isn't always the best way to go about it, because of reason we can see later. But the important part is you only have this one base class, so you can just write base. So it's already clear which class we're talking about. It's enemy, so base automatically refers to enemy. You don't need to write it out specifically. And we can do the same here. We also call the constructor. Could do that with 2. But we can also use the parameters given to us here. We could even make calculations. Or we could have private stick get random. Whatever could be in here. Could have get random call a method. So this is a method call as if it was normal code, which is a bit weird. It's a specialty of constructors. But this way we have a normal constructor for slime that will automatically initialize as an enemy with 2 health. Or we could call the constructor that gets provided integer value, like we did up here. That will then pass on that value to the constructor and enemy. So we could do this instead. And we'll do the same in here. Public golem, which we'll call the base class, with health. Let's not do default constructor. Let's do it like this. And we do it in here as well with dragon. And that way we have fulfilled the criteria for all the slimes, golems, and dragons we want to create. They all have a constructor that will refer to a specific constructor in the base class to initialize everything. And I made a mistake. What? What am I missing? Oh, right. Right, sorry, we haven't gone there yet. Sorry. So, what's complaining about is slime equals new slime. So if I do this, I create a slime. And this slime has an attack method that I can call play on. Like so. No problem. And this will call the attack method in slime, which will then redirect it to the attack method in enemy with a damage value of 1. But up here, just like with interfaces, we're talking about an enemy. Even though the enemy is a slime or a golem or a dragon, as far as the compiler is concerned, we are talking only about this object in terms of enemy, just like with interfaces. We specifically said enemy, so we're limiting ourselves to whatever is available through enemy, even if there's other stuff available in the specific class. even if it's the exact same signature. So yes, enemy does not have an attack method that has only one parameter, only a player. Only this attack method that can receive a player and damage value. And that one is not accessible to us, so we can't do anything right now. What we need to do is provide enemy with an attack method that only receives a player and that is visible. Public void attack player. Now we have an attack method that we can use on player, and that should actually compile. Please compile. Thank you, it compiled. Just want to make sure that I didn't forget anything else. Unfortunately, this has a weird side effect now. We have an attack method in enemy, an attack method that receives one player. If I have slime, I shouldn't have deleted that. If I have a new slime and say slime.attack attack player, which attack method is it calling? We're going for slime.attack. Right, slime.attack. But slime has two attack methods. One is defined in here, and the other is defined in here. Slime extends enemy. That means it adherents from enemy. That means we have a fully functional, valid method inside enemy that we could call. This is not an interface. With an interface, we would only have the signature. We would only know that there is an attack method, that's it. But because we inherit it from a class and not implement an interface, we have now two full, valid, functional definitions for a method called attack that receives one player. What do we do? Well, you might think simple. We call this method if we call it on a slime, and we call this method if we treat it as an enemy. So up here we call the method an enemy, and here we call the method in a slime. And yeah, okay, that could work. Though the compiler would probably prefer us specifying that a bit. For one thing, it is possible. We would have another keyword in here added so we can help the compiler identify these little inconsistencies, but there's a better way to go about this. And the reason we might want to go in a different direction here is, why leave it up to chance? Why have one method up here and one method down here with different behaviors, potentially? Just depending on how we call the method. If I would call attack here, in the context of enemy, I still wanted to use the method of slime. The same as it would with an interface. I don't want to cast it to slime and then call attack. That kind of defeats the whole purpose of putting that in one large array. So I need to have this method in here. So enemy has the knowledge of a public attack method with only players. So I can call it from the context of I only see an enemy. But internally I wanted to redirect to this attack method if it's a slime. And this attack method if it's a golem. And so we mix the concepts of interfaces and classes, class inheritance a bit. Or maybe, no, before we do that, let's start with something simple. The attack method right now is a public void attack. It is visible to everyone. It doesn't return anything. It has a name called attack. And it receives one argument, a player. That's how we define our method right now. We can specify that this method is just there to fulfill the basic needs of an enemy. But it has no priority. If you see anything that fits better, like this attack method in Slime directly, use that instead. Want to somehow mark this thing as use in case you don't have an attack method, right? Default to this, but if you have any other attack method available, use that instead. Want to somehow set the priority as low as possible. And we can do that by adding something before the return value, like another modifier to determine what this method does. We can think of this as this is the definition of what the method is, what it returns, how it's called, and what it gets. Everything in front of it determines some modifiers, some specifiers for this method. So far we've only used the visibility and sometimes the keyword static to make sure it's not bound to a specific instance of the method. We're interested in another sort of modifier. And this modifier is the keyword virtual. Which is a bit misleading, I think, because everything in here is virtual. It's all inside a computer, but who cares? Virtual is a keyword that tells the compiler this method is technically here. You can call it, it exists. It even has code if you need to. Could make it default to player. Good. Just give him 1 damage by default. Just if I don't provide anything better, at least hit for 1 damage, which we'll call this method up here. But Slime, for example, now let's say Slime will keep that as is. Slime doesn't change that. Slime will accept the attack method as it is. So we call it on Slime right now, here or here. It will default to this one method. It is the only attack method available for Slime. So it will call this, which fits because it's only 1 damage, which is what a Slime should do. Golems, however, should hit a bit harder. We do provide a attack method specifically for golems. And we want the compiler to always use this attack method over this default attack method from enemy. We mark this as virtual to indicate that it is fine to ignore this method, to make your own version of the attack method. I will always defer to the one you provided. And at the same time, on the other end, when you write the method, you have to specifically tell the compiler, I want to define my own behavior for this class. Doesn't matter what the base class has defined, I have a better version of that, a more specific version of that. Enemy is very general. I have a very specific need that's unique to me. So take my method that adheres to my specifics. And that needs another modifier where before we had virtual to indicate don't care about me, I'm just a fallback. Here we say override. Same down here. We tell the compiler that this attack method overrides any behavior you had before in basic enemies. Override and virtual always come in pairs. You have at the bottom an enemy, the base class, which has a virtual method just to say I have this capability, but it's not very specific and it's just baseline, it technically works. It might even do nothing. But it exists at least. Better than nothing. And then above that, and the classes that inherit from that base class, from enemy here, they say I'm overriding this behavior. I'm specifically saying this attack method that exists in enemy, I have criteria that need to be fulfilled. I have some specific behavior in mind. Whenever you call attack on me, doesn't matter if you call it on a golem or on an enemy that secretly is a golem, call this method. So a golem dot attack layer. Right. Whatever. Very weak golem, 1 health. If we call attack on the golem, it makes sense that this method is called. We call it on a golem. But even if we call it on this golem within the array, in here, if we look at it from the perspective of just enemy, where we would call this method, the compiler understands that, wait, attack is virtual. I need to pay attention now. In the background, the computer will now check, because it's virtual, what type is it actually? Like I'm looking at it as if it was an enemy. Okay, that's fine, but this method is specifically marked as virtual, as if you have something better, use that. Don't care about enemy. So it needs to look up in the background, what is it really? And it sees that, oh, it is actually a golem I'm looking at. And golem does provide an override for attack that I should use instead. So that's what I'm gonna call. We specific to the system. Do not care about the viewpoint. Don't care about the specific class we look at it through right now. Words. English. Don't care about the way we look at the specific object right now. It is a golem. So treat it as a golem. Ignore the specifics. Ignore the general definition. Look for the specifics. So we have a base class enemy that slimes can inherit from, which by default will have only 2 health. And golems inherit from, which have a defined health, which is just passed on to enemy, to the base implementations, and which has a more specialized attack method that overrides the default behavior, the virtual method. And Dragon as well. Comes with its own health definition, always required, and it overrides the default attack in the base class. So far so good. These are some basics. We can go a bit further here. We could, for example, public class super slime. We can create a super slime, which is different from the normal slimes, because it's super raw. And we could make a super slime by inheriting from enemy, sure. But it is a slime, so let's inherit from slime. Now, slime itself has implementation for default constructor and one that provides health. So we need to still provide nothing. if we don't provide anything, it will call the default constructor. And the default constructor, let's write it out specifically. Slime, like this. This would be the default constructor, if you remember. The default constructor, by default, always has this, which I never wrote out before. That this is part of the default constructor. It doesn't have any parameters, it doesn't do anything, and it does call the constructor of the base class, but also without any parameters. And sure, we have a constructor here that requires an integer value, but we do have a constructor that doesn't require any. So the default constructor in Super Slime does have a way to construct the entire instance. It can go through this constructor in Slime, which will then use a default value internally to create the necessary stuff in enemy. That's what's happening here if I just have Super Slime as is, but it's a Super Slime, let's force the value. Super Slime, yeah, int help, base help, and not do anything else. We create a Super Slime by providing it with some help. Super Slime. And it will be equivalent to a dragon. Pet. Very dangerous. Foe. Oh, foe. That's a nice word. Should have used foe maybe instead of enemy. So that's Super Slime there. And Super Slimes hit hard. Well, maybe not as hard as a dragon, but at least as hard as a golem. Oh, let's go in between. Like that. Now you notice Super Slime has override void attack. Slime didn't have an attack method, so okay, sure, we override the default attack behavior with Super Slime. We have a virtual method down here in enemy. We don't override anything in Slime, but we then do override it in Super Slime. Makes sense. This is still valid. The virtual here means whenever we call attack on an enemy, the compiler or the computer at runtime should figure out what are you really. I'm looking at you as if you were an enemy, but you marked this method as virtual, so I have to figure out what are you really. You're a slime, okay. Wait, you're Super Slime even. I have to call this method now. If you're slime, I call this. But if you're a Super Slime, even more specific, I call attack down here. Only the very first method in the entire chain, the most basic of all your base classes, that's where you mark it as virtual. And this will now be a virtual method, one that you need to look up for the real type through the entire chain. Even right now, here, slime. We call attack on slime. And we do have an implementation for attack for slime in here. But if I create a Super Slime and store that in there, I'm looking at this Super Slime as if it was a normal slime and call the attack method. I'm still gonna call Super Slime.attack. The attack method itself is fundamentally marked as a virtual method in the base class, the origin of it all. Even if I'm looking at this as a slime, I still know this attack method is originally virtual. I need to find the most specific version of it I can find. So I'm going to the real class I have and try to call it there. Only if it's not in here. I will then go to this, the slime variant of the attack method. which is now the most specific version of the attack method I can find. And if that's also not present, then I will go to the most basic version I have. We always go for the most specific iteration of the method we can get, because it is marked as virtual, as please do defer to the most specific one. Here's just the base implementation. So slime doesn't override it, but it could override it, and we would still call attack from super slime when call attack here, or call it for this super slime up here. Inheritance can go down infinitely, in theory. I mean, there are memory concerns on a real computer, but still. You can inherit from a class, and then inherit from that class again, and inherit from that class again. That's not an issue at all. Just like with interfaces, you can have an interface that implements another interface. Just means that whatever a slime has gets added to enemy in here, and then all the stuff in enemy and in slime are present for super slime. So public void oh no, let's just jump. Let's just jump, it's fine. Not writing any code in here, but in theory, slime has a jump method now. That means super slime has a jump method as well. Super slime has an attack method and a get attack method and a help field, but it also has a jump, which other enemies don't have, but slimes do have. And so super slimes, which inherit from slime, also have a jump method. And I could mark it as virtual and then make an override here if I want to. Public override void jump, which will then do a super jump or something. And the overlap with interfaces, I think, is something for next time, because I don't want to squish that in the next 10 minutes. But these are the basics. We have some similarity to interfaces. We mark it the same way, and we do have the same basic advantage of we can treat it as all the same, despite being specific different classes. We can all store that in one array, and we can all call the same method on all of these. The difference is that with interfaces, it's just a contract, we just say they have it, but these classes and structs are written entirely different from one another. Entirely independent. You could drop the interface and they would still work. With inheritance, with classes that inherit from other classes, you get the full code already pre-written and you just take that. If I were to remove this class enemy, none of these work anymore, because they all work based on this code. They all just build on top of what already exists in here. And that's all we have to talk about for today. Inheritance. Didn't quite work out with the pacing as I wanted to. I might have repeated myself a bit too much, even if it's important. Also, I'm thinking of finally switching to an IDE, but it's technically too early. I still want to finish at least classes out. But it's getting kind of confusing to read through all of this. Even if it's good training. Maybe clarity is more important than rigorous training. Now let's finish off classes at least. Next time. Then maybe in 2 weeks we can start with proper working environments. Right then, thank you for joining in. Have a lovely Sunday, and till next time.